distant past, it may have begun like this for a very young planet called Mars. It was an age of volcanic activity. With volcanoes came their gases, including water vapor. These gases condensed and formed rain. In its beginning, it rained for countless years. The rain cooled the planet's surface. The rain eventually formed streams. These cut channels in the planet as the waters flowed over the terrain. The waters continued to grow larger in size. Streams widened. Small streams emptied into larger ones, creating rivers or oceans. This is the past history of Mars as some see it. This is Mars today. The once powerful volcanoes of Mars appear to be extinct or dormant today. Time and erosion have covered their once molten lava with a mantle of dust. Yet volcanoes are still present, and larger than any on Earth. Olympus Mons is the largest known volcano in the solar system. It is 3 times higher than Mount Everest. Mars also has a system of canyons. The U-shaped walls indicate that rock slides and avalanches have helped shape them. 4 times deeper than the Grand Canyon, these canyons might be 150 miles wide. They may extend over a distance of 2,000 miles. What forces could have formed these canyons, and when? And what about the water that once apparently filled these eroded channels? Once, these may have been rivers or tributaries. Today, the water is gone, leaving behind dried-up riverbeds. What happened to the water? When did it disappear? And what removed it? The water that may still exist on Mars is probably located in part at the poles, existing as polar ice or frost. It is joined there by frozen carbon dioxide in temperatures of -190 degrees Fahrenheit. This is the coldest place on the surface of Mars. Although water appears to be frozen in the ice caps, and although it may exist in the crust as permafrost, there is relatively little water on Mars. Mostly, this is a planet covered with dust, and the dust is moved by winds. Usually, the Martian dust storms last only a few days, but they carry dust up to speeds of 250 to 300 miles per hour. The dust storms have apparently contributed to much of the erosion that has taken place on Mars. The dust storms have helped shape mountains, volcanoes, and other surface features. At times, the dust has even appeared to have formed dunes. So Mars is not without Earth-like features, although portions of its surface are pitted with impact craters. If Mars is so seemingly desolate, apparently covered with little water or oxygen, what could live here today? And further, how can we determine if life presently exists on Mars? The answers on how to detect Martian life are found aboard the Viking lander that rests on the planet's surface. Its cameras, with their mirrors, show us what is on the planet. Yet they are controlled from the Earth. Certain instruments measure the velocity of the winds and provide information on a variety of surface and subsurface conditions. After traveling 440 million miles for nearly 1 year, one of the most important things this craft must do is to reach into the Martian soil and return a sample to the lander. This would be an easy task on Earth, but on Mars, machines must act as our hands. Returning the soil to the Viking lander is the first step in searching for the answer to a question that can change man's way of thinking. This desolate planet, if it has life, could alter the thought that Earth alone has living creatures upon it. So the journey of the soil back to the lander is one of great importance. Once the material reaches the spacecraft, it is sifted as it falls through an opening into the interior of the lander. Some of the material falls into a chamber where it can be tested for the presence of life in a biology experiment. In this chamber, the soil is moistened with a liquid that includes food that Earth microorganisms thrive on. A sample of the Martian atmosphere is pumped into the chamber, and then the weight. If there are microorganisms acting upon the food in the soil, they will give off a gas. The gas will mix with the Martian atmosphere, and when it is analyzed by chemical detectors, it may reveal that life is present. While the first experiment is taking place, some of the soil is also falling into another chamber for a second biology experiment. This time, the soil is also moistened with nutrients, but the nutrients are tagged with radioactive carbon-14. If the organisms are in the soil sample, they will feed on the nutrients and pass the radioactive carbon off with their gases. The gases can later be analyzed by other equipment aboard the lander, and the presence of radioactive carbon will indicate the presence of life. In the third and final biology experiment, a sample of the soil has fallen into a third chamber where it receives a small amount of moisture and an atmosphere of carbon dioxide gas tagged with radioactive carbon-14. Simulated Martian sunlight is introduced, and if plant-like organisms are present in the soil, they will capture the carbon-14. Later, the original carbon-14 gas will be flushed out of the container, and the chamber will be heated to over 1,000 degrees Fahrenheit. If there is carbon-14 in the soil sample, it will be detected when released in the heating process. This would indicate plant-like organisms existing on Mars. what life exists on Mars today? Could there be creatures like those that abound on Earth? Exactly what forms of life could exist on Mars? The biology experiments are designed for the very small organisms, partially because of their abundance and their ability to survive environmental extremes. The Martian planet abounds with mysteries, from its volcanoes to its bleak landscape. We know this place only from a great distance. Its secrets are there for us to discover. But if we do not find life on Mars today, it may mean we just looked in the wrong places, or searched with the wrong instruments, or came at the wrong time. But if we do find life on Mars today, it will mean that life on Earth is not an isolated instance, and it will offer further evidence that we are not alone in the universe.
There were high hopes that the Viking missions might find clear evidence of life, but the findings were not clear, as we will see in a NASA film called 19 Minutes to Earth.
It was not just another day on the planet Mars. A spacecraft